if I say that I have figure A, B, C, and D is congruent to figure W, X, Y, and Z. When you label figures, you're always labeling them via the vertices. So how many angles are in each one of those shapes? 4, because there's 4 letters in each. Does it tell you what the shapes look like? No. Now, what happens here is that whenever you get this thing called a congruency statement, it tells you what matches with what. So I'm just going to draw a 4-sided figure. 4 sides, right? Okay. It's just 4 sides. I tried to make it look like nothing. Okay. So it's got 4 sides. What I'm going to do here is just kind of build it in here, and I'm going to say I'm going to start with A, B, C, and D. And it's going to match up with the other figure, W, X, Y, Z. So the idea here of what's called a congruency statement, it specifically tells you what angle matches with what angle. For example, what's the first letter in the first figure? What's the first letter in the second figure? W. That means that these two angles, these two angles have to be congruent. How do you make congruency marks on angles? You remember? And that's more for segments. We do little, but yeah, just little hook like that, little arc. B has to be congruent to what angle then? See the pattern here? C goes with, good. And then last but not least, D and Z. A lot of times when we get to 4 tick marks, instead of making 4 arcs because it gets kind of messy, I usually do this. And just as long as it hooks together. Yes, sir. As long as they match up, it still works. Yeah. I was just. Yeah, all I was doing is just showing that the letters themselves correspond to each other. Okay. Now, within these figures, what else do they have? Not only do they have angles, they have what? Sides. Whoa. That's okay. They have sides. So if I'm going from A to B, what side length matches with A to B? W to X. So these two have to be congruent.
And you know that two ways that you could look at that. It's the first 2 letters and the first 2 letters. I could also look at it as it's between 1 and 2 ticks, and it's between 1 and 2 ticks.
You're looking for what we say this all the time, correspondence. You're looking how they correspond to one another. Okay? It is really simple as we get into this. So then obviously between B and C has to match up with XY. CD has to match up with YZ. And then last but not least, again, sometimes instead of making 4 tick marks, I usually use like a little bit of a V symbol, something like that. Or if you want to put 4, whatever, as long as it matches up, it's cool. Some people put a circle. I think you use a circle, don't you, Mr. Roy? Sometimes you put a circle in there?
Yes.
Yeah, and it doesn't matter, as long as it's consistent. If you want, yeah, go for it, okay? But yeah, the idea here is, guys, is that you're looking to see how the correspondence of stuff works. The reason that we're able to do all this stuff is because of that thing that's called congruent. Remember, whenever you're congruent, it means you're equal measure. So if we start piecing this together, if I say that AB is 7, what's the other side have? What does WX have to be? 7. If I say that BC is 12 and XY is T minus 3, what would you do to solve for T? Exactly what you do. Everybody see that? what's going to happen here is that we'll take this from just very simple, match the letters, to a quick statement of what matches to solve algebra. We see that from B to C has to match up from X to Y because of the tick marks. If I know that BC is 12, that has to equal to T minus 3. What's T? Very good. That's the natural step as we get into these things. It's very, very easy. Okay? Let's see what else we got here real quick. Oops. This one might be tough to draw. Here's what we have as our congruency statement. DEF is congruent to SPQR. And they're asking us to find X and Y. Let's make it blow this up just a little bit better.